Okay, and then we're going to do what's called the IVT, which is intermediate value theorem. We're going to do these two first. I'm going to give you your worksheet. We're going to go do those problems together, so you'll see how the homework is tonight. And then we'll do intermediate value theorem. So the example says, find the value of K that makes each function continuous over the given interval. And f of x equals 2x minus 1 for x is greater than 0, and x squared plus k for x is less than or equal to 0. Actually, I hated this one because I wrote it backwards, but it is what it is. I'll give you a minute to write that down. Find the value of k that makes each function continuous over the given interval. While you're writing that down, let's go over the 3 steps that I just showed you on homework that you need to know when a function is continuous, okay? Step number 1, you need to be able to plug it in, and get out an answer. Step number 2, the limit from the left has to be equal to the limit from the right. And step number 3, what you plugged in has to equal that limit, okay? So we have a problem here. There's a problem area going on at a certain point. Anybody want to take a wild guess where that point is?
0.
0 is our problem, okay? So we want to check this. You okay?
I'll just tell her not to get a test.
Oh, yeah. Is that it does exist. I just don't know what it is. How do I figure it out then? Well, then you check the left and right limit. Okay, so if I'm continuous, then the limit as I approach 0 from the left should equal the limit as I approach 0 from the right. That's what the definition point 2 in continuity says, that the limit should exist, okay? So let's plug 0 into the top part. Well, actually, take that back. Let's plug 0 into the left. The left would be the bottom. That's why I should have switched these two, but it is what it is. If I plug 0 into the bottom, I would get out what value for what expression would come in here. Plug 0 in for x, by the way. Okay. If I plug 0 into the right function, which in this case actually happens to be the top function, if I plug 0 in for x, what do I get out now? Yes. That took me a minute. I was like, no, is it 1? Duh, yes. So, hey, did we just figure out what k is? We did. For this function to be continuous, k would have to be a -1, because then you wouldn't have a problem at 0. You'd be able to just smoothly draw the curve and it would be fine. Does that make sense? It's pretty easy. Now we're going to get a little bit more challenging because, you know, that was obviously simple and we need to work harder and be smarter.
So just like all the way up, right?
-1. Yeah, you just check your left and right limits. That's literally what we're doing. We're going to find A and B to make the function continuous. And this time it's 3-piece. 2 such that x is less than or equal to -1. Ax plus b such that -1 is less than x is less than 3. And -2. To find out, first of all, where are your problem areas at? What are the 2 points that we're going to have to check from -1 and 3? Okay, so we know we have our problems occurring. They could be holes, they could be asymptotes, but we know it's at -1 and at +3. So you're actually going to have to do 2 different limits for 2 different x's. You're going to have to do a limit from the left of -1 and a limit from the right of -1, and a limit from the left of 3 and a limit from the right of 3, just like we did up here, but now we've got 2 of them. Does that make sense? Okay, so I need to check that, and this is the whole point, that your left limit is equal to your right-hand limit. That's the whole point of what we're doing, most of what we're doing. So I need to check that the limit as x goes to -1 from the left equals the limit as x goes to -1 from the right. And I need to check that the limit as x goes to 3 from the left equals the limit as x goes to 3 from the right. Yes or no, is that making sense to you?
Yeah.
Okay, so now, which of these three pieces would be the left limit of -1? The top, the middle, or the bottom? Which one would be the left? The left. Left less. Top. Right. So if you plug in -1 for x, well, there is no x. What is your limit then for the left side? Put 2. What would be then the limit from the right? Top, middle, or bottom? For -1. Middle. And can I just stop you right here? It always is going to go like that. It's going to go top to middle. And then guess what this one is going to go? Middle to bottom. That's a 3-piece how it works, okay? So listen to what I'm saying. Plug a -1 in for x into the middle. What would you get out if you plugged a -1 in for x? -a plus b. Okay, now, can't do anything because don't know what a is, don't know what b is. That's what I'm going to solve. So I'm going to go to this side now. Plug in 3 to the left. Would the 3 plugging into the left be into the top, middle, or bottom? We just talked about this. Middle, put a 3 in for x. What would be that expression then? 3a plus b. Plug a 3 into the right side, which wouldn't that be on the bottom? Equals -2. Oh, what have you just created? That is called a system. Good job, John, with your... You now have a system of equations. Actually, I hate writing it that way. 3a plus b equals -2, and -a plus b equals +2. And I would like you to solve that system and tell me what a and b equals. We get -1 and 1. That's it. Okay. So now I'm going to give you the homework, and we're going to do. Okay. Here we go. Let's start off with this front side, picture 1, 2, and 3. So again, let me go over the 3 rules for continuity. If you want to write this down, you write it down. You need to have. And you have to exist if you plug it in, okay? So f of a exists. You have to be able to plug it in. Step number 2, your limit as you approach a from the left needs to equal the limit as you approach a from the right. It has to equal some, we'll call it L. I don't know, some number L. And step number 3, these two have got to be the same number. What you plugged in has got to be the same as the limits. The f of a needs to equal the L. So looking at these 3 pictures right here, by these definitions, where does picture 1 fail? Does it fail at this number 1, number 2? Does it fail when I plug it in? If I plug in, do I have an answer? Why does it fail at 2? Aren't the limits not the same right here? The limit for the left? If I go that way, limit from the right, those aren't the same limits. So the limit as x approaches a from the left is not equal to the limit as x approaches a to the right. You can write 2. Sure, Gray. That was Gray. Hey, what's wrong with number 2? Are the limits the same?
Oh, there's a hole.
There is a hole, but are the limits the same? Aren't the limits the same? Yes, even though there's a hole? So then where am I failing? But it doesn't exist. There is no f of a.
There's a hole. That's what I said.
There's a hole. All right, and then what's wrong with picture 3? What's not equal? Does f of a have a point? Yes, it does. It's closed. Do the limits exist? Yeah, the limit does exist, but what's wrong with those two? They're not the same. This would be like, f of a would be like, I don't know, 1, whereas the limit would be 2, and those need to be the same. So there you go. Okay, so there's 3 reasons why, that's why we need to do continuity. All right, so now let's go to number 4 together. It says sketch each problem, don't sketch each problem. Is H continuous at x equals 1 if A is 3 and B is -3, and justify? So they actually gave us A and B, and they want you to justify if it works. So let's plug in A, 3, and let's plug in B, -3. What would then this expression be in the middle? If I plug in 3 for A, wouldn't I get 6x?
Yes.
And if I plug in -3, 6x minus 3. Okay. So now we're going to do our 3-step process and see if this is continuous. So step number 1, can you plug in 1 into the function and get out an answer? If you plug in 1, what would you get out? Just -3, correct?
Yes.
Okay, plugging in 1 would be this guy right there. All right, step number 2, does the limit as you approach 1 from the left equal the limit as you approach 1 from the right? Okay, so again, which one is the left-hand limit of 1, the top, the middle, or the bottom? The middle, right? That's the left piece, that's the less than 1. So plug 1 into here right now, what would you get out? 3. What would be the right side of 1? Top, middle, or bottom? Bottom. To the right, greater than 1. So that limit is -3. Are those the same?
No.
So am I continuous at 1? Not continuous at x equals 1. That's how you justify. You go through all 3 steps. Okay? All right, number 5. What is your left and right hand limit of a not equals to? You did a question like this yesterday. Do you remember what it was? It's only the top, okay? The top, when you have a not equals, your left and right hand limit are both of those. Did you know that? Okay. All right, so let's go through the 3 steps right now. Step number 1. Can I plug in 2 and get out an answer? What is my answer when I plug in 2, according to that piecewise? 3. Step number 2. As I approach 2 from the left and I approach 2 from the right, do I get out the same answer? Now, again, we just talked about this. With a not equals, this right here, this piece right here is your left and your right. It is. It's the left and the right. Plug in a 2 right now. What would you get out? Plug a 2 right in there. 5. So my limit is 5, but my function when I plug it in is 3. Have I passed test 3 then? No. Not continuous at x equals 2. This right here, by the way, looks like this picture right here. That's what it actually looks like. It's a straight line, x plus 3, and then it's a little hole right there. So for those of you who are more visual, that's what you've actually just graphed. That's why it doesn't draw correctly. All right, almost done. Now we're going to do 6, 7, and 8. And you're doing half your homework right here. And then we get to finish with 9, 10, and 11. I know, you're welcome. You're welcome. They are hard. You have to start thinking hard because guess what? The title of this class is Calculus. I thought it was little pre-algebra 7th grade math. No, calculus. All right. Find A and B so that the function is continuous for all reals. Where do I have a problem at in number 6? What's my problem? 0. Okay, so here's what you want to do. First want to plug in 0 and see if you can get out an answer. If you plug in 0, can I really get out an answer for A? No. Okay. If that doesn't work, then you check, listen to me, the left and right limits. So the limit as you go, x goes to 0 from the left, does that equal the limit as you approach 0 from the right? For both of them, yes. So I'm going to ask Braxton because he's struggling on this. Which one of these is the left limit? Which piece? The top piece or the bottom piece is the left? Good job. All right, everybody, if you plug 0 in for x right now, listen, doesn't this look magically something like we've done before? Ooh. The limit as x goes to 0 of sine x over x is 1. So what is this actual limit on the top then? You're brilliant. Okay, let's plug in 0 for x, not for a, onto the bottom. What would you get out then if you plug in 0 into the bottom? A minus 0, which is just? You just figured out what a is. I know. All right. 7 is a doozy. I'm going to have to do 7 with you and 8. So I'm doing all of these because you're going to have to do all that by yourself. It's all right. You can do it. The other class did and got it done. All right. Step number 1. Can you plug in? Oh, where's my problem at? This is a weird one. Where's my problem at? A. What weird is that? But that's okay. We can do it. What is the G of A? Plug it in, plug it in. What does it say it is? 6. Isn't that what that piece says right there? When I plug in an A, I should get out a 6. Okay, that's going to become important. Step number 2. The left-hand limit as you go to A from the left, does that equal the right-hand limit as you approach A? Okay. So remember, how did you know it's both? Because it's the not equals to. So let's do something that we've done when we were working with limits. When we worked with limits, didn't I tell you to plug it in? It won't, if it doesn't work, factor, yes? Can't you factor this right now? What does that top factor into? Oh, and what's going to cancel right now? All right, so now plug an A in to that top expression. What would you actually get out? It's an expression. What would you get out? Wouldn't you get out A plus A or 2A on the left and on the right? They're both the same. It doesn't matter. What does the third step of the continuity say? So what would be my equation that I would use?
2A equals 6.
Beautiful. So what does A equal? Done. This is hard. I'm not trying to make it easy, but I'm trying to show you that you do the same process every time. Plug it in, check your left and right, plug it in, check your left and right, set them equal, plug it in, check your left and right, okay? I want you to do 8 by yourself now. Right. Does that make sense to you? Okay. So then the left and right limits are only on the top when it's not equals. So I cross it off. I plug in the A, and I get out 2A. So according to step number 3, this needs to equal that. Okay, do number 8. Number 8 is exactly, look at the notes. This is why you take notes. You don't just take notes for fun. You didn't take notes.
I know to circle the -1 and -1.
Good job. Circle the -1, circle the 2. You're going to have negative A plus B. There's nothing I can do there, so leave it alone. If I plug 2 to the left, which is the middle, I would get 2A plus B. If I plug 2 into the bottom, I get -4. Those two are what you use your system for. And you'll get A to be -8/3 and B to be +4/3 if you did it right, okay? Just show how you work. We are going to do 9, 10, and 11 now. But I have to give you the definition for it. And then I will actually use 9, 10, and 11 as my examples to make it easier for you. that make sense? Okay. So this is the whole point of today. This is actually what I wanted to just focus on today. This is called the intermediate value, yes, you are taking notes, theorem. Also known as IVT. Okay, let me give you, I am going to give you the formal definition because I think it's important that you read the formal definition, and I'm going to give you a visual drawing of it, and then I'm going to show you step by step what to do every time you see these problems. Okay? And pretty much here's like the drawing, because I think the drawing actually makes sense, that if you have some curve, some f of x curve like here, and you're within an interval a and b, would you all agree, like if I go up here and then I go over here, this right here would be f of a. And then if I go up here, oh, this looks terrible. And if I go over here, this would be f of b. Does that make sense to you, right? You're in between some interval a and b. You have an f of a, you have an f of b. The intermediate value theorem says that if there's some line that goes across here, and let's call that value right here, let's call it k, okay? That I should be able to then find at least a point where it intersects, at least one point where it intersects that curve. Does that make sense to you? That point we're going to call C. And that's the point we're looking for. We're looking for that value in between. What the intermediate value theorem really does for us, it just helps us find zeros. Remember your x-intercepts on the x-axis? Now, I know what you're thinking. You're like, well, we did all that last year in pre-calc, Mrs. Seta. We did, okay? It's just another way to help you find it, and you have to learn to apply the intermediate value theorem in calculus. That's the whole point. So let me give you what's called the formal definition. I always think it's important because math seems so scary to people when they read these formal definitions, when in all actuality, it's quite easy. But you have a continuous curve, y equals f of x, so that's the curve I just gave you. And it is on a closed interval, AB. And k is a number between f of a and f of b. That's what I just drew for you up here. There's some value k that's between the y values, f of a and f of b. Then according to the intermediate value theorem, there must be at least one value c that's within a and b such that the f of c would equal k. I'll give you a minute to write that down, and then I'll explain what we do every time to apply the intermediate value theorem, because it looks so nasty, but it really isn't that hard. It's just plugging in and checking, and then plug it in and check, and plug it in, and it's just the same process over and over again. So it seems nasty, but please don't think it is, okay? And I'm actually, like I said, I'm going to do the worksheet that we just had. I'm going to use 9, 10, and 11 as our examples, okay? So if you bear with me, and I'm going to write it down because I need more room than what they give me here. Okay, so these are the steps. Step number 1, plug in and find f of a and f of b. Plug in and find f of a and f of b. So I'm going to use question number 9. They gave us f of x equals 2 plus x minus x squared. They gave us the interval 0, 3, and they told us that k equals 1, okay? So what would be my f of a? What would I plug in? F of 0 and f of 3. So find those now for me right now. Plug in 0, what do we get out? 2, is that right? And plug in 3? Negative 4, yeah, I think that's what I have. Everybody got that? Okay, now, here's the thing. Look at this picture. First thing you have to check is k in between what you just found. Is this guy in between those guys? Is 1 in between negative 4 and 2? Because if it's not, you can stop the problem right there. You can actually say, I cannot apply the intermediate value theorem, which will happen, which you'll be happy about, by the way. Okay? So it is, but that's a step number 2. Check that k is between f of a and f of b, which we did. So now we have to go to step 3. Boo, but it's all right. It's fine. Once you do the checking and it works, you set f of x, your function, equal to k and solve it. Okay? If this is between the two of them, which it is, then you're going to set your function, the original function right here, equal to that value of k. This y is equal to that y. So 2 plus x minus x squared equals 1. This guy is equal to that guy. And we solve for x. Let's see. I set it equal to 0 whenever I have a quadratic. So positive x squared minus x minus 1. Anybody know how to solve that? What? Quadratic formula. I'm going to save you time because of the time of this video in the class. X is equal to negative 0.618 and 1.618. Remember, you always have 2 values for quadratic formula. Once you get your values for x, you have to do one more check and then we're done. And I know this seems like a long period to do, but I promise you it'll get faster. Your values that you just found, the x values, are actually your c values. Are those 2 values within the interval a and b? Are both of them between 0 and 3? Are both of them between 0 and 3 right now? No. So the only true c value is 1.618. So that would be step number 4. Check. Whoops. Check that your answer is between A and B. All right. I'm going to do 10 and I'm going to do 11 with you again, and you'll see there's a flow to this. I promise you, there'll be a flow. Right now it's very choppy. But what you do is the same thing. Plug in your F and A, plug in your F of B, check to see that it worked, that they're in between, the K is in between. Solve for X, set them equal to, and then check to see that it's in between A and B. It's annoying, but it's all about checking and checking and checking. All right? So let me do 10. And then I will do 11 with you, and I promise you it'll go faster. You'll be happy. 10 says f of x equals square root of 9 minus x squared. Your interval is, negative 2.5 and 3, and your k is 2. Okay, what was the first step that I do? What's the first step? Plug in what? Plug in f, plug in negative 2.5. Someone do that for me. Let's all help each other out. And someone plug in 3 for me. 3 is actually easy. I can do 3 for you. It's 0. What is negative 2.5? 1.658. Okay. What did I do after that? I checked something. What did I check?
Okay.
A K in between these two guys right now? You're done. Cannot apply IVT. Done. Wasn't that lovely? And that will happen on homework tonight, by the way. If it's not in between, done. You can't even go on. All right?
Hey,
Number 11, last one.
so you're leaving us to number 9, correct? Or no, we already did that.
I did 9, I did 10, I did 11. I'm leaving with the back page. The back side is what you're gonna have to do.
I just never.
Oh, John. It's okay, John. We love you. All right. Again, this is why I like math, because if you do the same thing every time, you get into like this rhythm. It's almost like muscle memory, okay? What's the first thing that I do? Plug in 2, plug in 5. So plug in a 2 right now. You should be able to do that. What's 2? You get 1, right? Okay, plug in 5. What do I get? A 4th? Okay, check. Is that in between? Unfortunately, it is.
I don't know.
Okay, yeah, well, 5, 6 is like 0.833 repeating, so it's between a 4th and whatever. Okay, if it passes the test, then listen to me. Then you set this function equal to K. You set them equal. So you do, okay, 1 over x minus 1 equals to that K then, because this must be the Y that it equals. Anybody remember how to easily solve that when it looks like this? Yeah, cross multiply, butterfly, whatever you call it. 5x minus 5 equals 6. 5x equals 11. X is 11/5. We have to do another check. Where does this guy have to be between?
A and B.
A and B. Is 11/5 between? Yeah, 11/5 is like 2 point something. Right? Because 11 divided by 5 is about 2. So yes, that is your C, 11/5. All right, you have to do the back side of that worksheet. Okay? I'm going to tell you right now, the one that I think is the hardest is number 7. If you can do number 7, I might do something for you. No. Maybe. I don't know. All right. But you have to do A, B, and C, 6, 7, and then it says 1 A, B, and C also down here, which is the Inverted-Value theorem. And that's it. Okay. And I have to get rid of John's bemoaning.
I want to play it.
Noelle would be disappointed in her
Noelle
little
doesn't
friend.
watch these videos.
I want to play it.
Noelle could watch the